All right, I'd like to welcome everyone to another GigaOm webinar, this one entitled Data Virtualization and Cloud Olap. How can they improve your BI? So that's a lot of words and a lot of syllables, but basically what we're going to talk about is how the worlds of data lake technology, once known as big data, and some of the older concepts, the more classic concepts from BI and data virtualization can all fit together in a way that makes sense, that is sort of respectful of analytics history, if you will, while also really embracing the things that have changed, getting the best of both in effect. And our sponsor knows a thing or two about that. We have AtScale here as our sponsor, and we have a co-founder of AtScale as our guest speaker. And I'll introduce Dave in just a moment, but first I'll introduce myself. I'm Andrew Brust. I'm a lead analyst at GigaOm, focused on all things data and analytics and business intelligence and artificial intelligence. I covered that same space as a journalist slash blogger for ZDNet. And I also, through my own company, do independent work with companies in the space. Enough about me, though. Our guest, whom I'm very happy to have on board today, we keep meeting each other in this industry through different eras and different phases. So it's great to have Dave here as a guest. Dave Mariani is the co-founder and the chief strategy officer at AtScale. And Dave, I'm going to ask you to tell us a little bit about what that entails, what it has entailed as AtScale has gone through, its progression, I suppose. And I know a thing or two about what you did prior to AtScale. I'd love to have you kind of share some of that with the audience, because I think it informs the discussion quite relevantly.
Great, thanks, Andrew, and thanks for joining up and doing this with me today. So Andrew and I sort of have been crossing paths for quite some time, both when I was at Yahoo, later on at Clout. And so the idea for AtScale, and the reason why me and a few ex-Yahoos started AtScale, really came out of our experience at Yahoo. So it was a very exciting time. We were inventing the Hadoop and the Hadoop open source project. And that's where all our data was landing, was in a data lake. But I was responsible for data and analytics at Yahoo, which meant making sure that our internal users could use analytics to drive both revenue through advertising, as well as page views, which drove advertising revenue, as well as our external partners, our publishers and our advertisers who needed analytics to be able to run their business on top of Yahoo. So the problem, of course, was how to get the analytics from a data lake or even an Oracle data warehouse into the hands of a user, so that they can self-serve and do wonderful things. And what I found was the Olap model, which in my case was SQL Server Analysis Services, which is what I used, was a great vehicle for that, in that we built the largest cube in the world, 24 terabytes. So it was bigger by a factor of 5 than anything else out there. Didn't realize it at the time that we were doing something so crazy, but it was pretty successful. And it was successful because the end users loved it, because it drove self-service. And they liked it really for the 3 main reasons why I like Olap. Number one, the speed. So queries under 1 second. Today, we've gotten used to queries in the 10 or 20 or 30 seconds, and we think that's fast. Well, I don't think that's fast, and my customers didn't. So they really like the speed of Olap. They love the semantic layer. So the fact that you had measures and dimensions and business concepts, very simple concepts like a page view, for example, or an ad click. Common definitions where if those were defined in our individual BI tools, everybody came up with their own answer. So by having that cube, we were able to create that single semantic layer. And then we also, through MDX and the power of Olap, being able to have that language, that expressive language to describe business and business logic, gave us a huge amount of power. So I loved all that and loved all that about Olap, but of course it didn't scale for us. And 24 terabytes is ridiculously small, but huge for multi-dimensional Olap. So we started the company to bring the best of both worlds, the best of Olap, but with Olap on a modern architecture. So back to you, Andrew.
Excellent. So thank you, and that was a good preview for a couple things that we'll talk about. So we're gonna level set and talk about what Olap is and what it was, including expanding on the acronym. For anyone who doesn't know it, you will shortly. And we want to kind of talk about this notion of structured data versus unstructured data. The fact that the industry, I think at least, has kind of cast some dispersion over the notion of structured data, that everything ought to be unstructured, that is somehow its natural state. And really there can be a fusion of the two models. We'll talk about that. We'll talk about how this all ties into data virtualization, and get to a point where we can talk about the pros and the cons of Olap, and then a modernized approach that can reconcile those. We'll have a couple of polls as we go along. That's really our way to get to know those of you in the audience better, since there's too many of you for us to just take you all off mute and have a nice intimate conversation. But this way we can, at least in aggregate, get to know more about you. And then actually a more direct way for us to interact is if you submit questions to us into the GoToWebinar console. Those will get traffic cops a little bit sent over to us, and I will do my level best, to integrate those into the conversation as we go, rather than kind of segregate them all in some standalone Q&A section at the end. That said, if we end up with so many questions that we get stuck, then I may kind of arbitrarily say we need to move on, and then we'll come back to some of those questions at the end if that's necessary. So without further ado, let's start talking about this notion of structured versus unstructured, and maybe Dave, maybe you can help us get to an understanding where we don't, and this may sound absurd, but where we don't actually see those two things as mutually exclusive, that there is kind of a cooperative way to have structure and data that is perhaps stored in a data lake in an unstructured fashion. And I think, and I'll shut up in a second, but I think if most people consider the fact that they may be using data lake technology a lot today, but they still tend to be doing their visualization in what are in fact BI tools, then this notion of bringing unstructured and structured, there's already precedent for that. But how can we make that a little more explicit in our understanding, number one, and then number two, can we create a kind of marriage between these two? Dave?
Yeah, so I really think of it as separating how you store the data from how you consume it. And in years past, we used to create schemas for consumption, and that was the star schema, where you had facts and you had dimensions and they had relationships, and it was all sort of, the schema was built for the consumer, for consuming those dimensions and those measures. Today, it's like that's really a sort of foreign concept now, not to a lot of people, and it's not really suitable for the way that these modern data architectures want to be able to store the data for processing power. These MPP sort of architectures that don't like to do joins and table joins. So it's okay to store and use and leverage and store the data the way that these new modern data systems prefer. But adding structure on top of that, on that semi-structured or unstructured data, to make it consumable by the business, I think is imperative, and just makes it more usable, more consumable, and it gives you the best of both worlds.
Absolutely. So I like this working notion, and I think we'll keep building on it here, where on the one hand, we're talking about how data is stored physically, and then on the other hand, we're talking about how it's modeled or understood or abstracted for the purposes of analysis. And there is this notion of schema on read, but let's understand that even if you're doing schema on read, there is schema. It's just a question of when in the process that schema is imposed. Is it imposed at the time of querying, and is it done on a totally ad hoc basis? Is it done all the way at the other end of the timeline where before it's even stored, that schema is imposed? Or is there an intermediate where we can we can structure the data through an intermediate model after it's stored but before it's queried? And I guess it's that we're kind of pointing to. The other
Andrew,
thing I'll point out. Go.
Okay, just on that point, Andrew, we have customers that consume both from a cloud data warehouse as well as the cloud data lake like S3. So, when you think of it, you still can add that structure, that measure and dimension structure, even on a flat file. And there's different reasons for it, right? So you may want to consume from the data lake because you want to look at the raw data and whether that be dirty and not clean, but that's how you're going to understand what you need to do to it. And you may want to use the data warehouse for more data that's actually been blessed and clean. But so there's different use cases for either, but it doesn't mean that that having structure means that you can't do what you need to do to explore the data in its native raw form.
Absolutely. And I'll also just point out, I mean, lots and lots of people are using BI tools against even the most unstructured data, but let's imagine you're using Tableau. You get that nice little palette on the left of all your numerical fields that kind of go on the bottom left, if I have it right in my mind's eye, and then all the categories that you're going to aggregate those or drill those down by on the upper left. And those numbers are explicitly identified as measures, and those categories are explicitly identified as dimensions. And measures and dimensions are the atomic units, really, of what Olap is all about. That's where those terms come from. So whether folks know it or not, they are using Olap a lot of the time. We've just gotten a lot more forgiving and frankly, more agile, less waterfall about having to whip everything up in that form of measures and dimensions before even the first analysis can begin. So that then brings us into our level set where we can talk about what Olap is. It stands for online analytical processing, and that acronym was initially meant to contrast it with OLTP, which is really describes the kind of relational operational databases that everyone had been and for the most part still is using with applications. So you've got your operational data stores, OLTP, but what if you had a specialized store just for doing analysis, both so that it's optimized structurally for that, number one, and number two, so that you're not burdening the application database with the analytical questions that come up. And like the slide says, it's based on this notion of measures and dimensions. And when you put measures and dimensions together, now you get what we like to call a model. It's just that we used to call those cubes. And cube was really meant to contrast it with a table. A table has rows and columns. A cube is kind of like a table. It's sort of a square, but it's multidimensional, not just two-dimensional. And then we've got a couple of technologies, some more acronyms laid out here. And I'd love it if you could help the audience understand some of these things. There is a lot of alphabet soup here. So especially if you could help us understand the value of MDX and what that is and how it benefits me even if I'm not learning it and writing queries in it and this difference between Rolap and Molap as we do our little Olap history lesson here. Go right ahead.
Okay, great. So yeah, MDX. So MDX was really a language invented um, uh, back with Microsoft back in 1996 when they actually bought Panorama Software, which actually developed MDX, the initial cut of it, and that became SQL Server Analysis Services that we know today. So what is MDX? It is SQL, but it's SQL-like, but it's made for really doing cell level operations. And if you think about, a spreadsheet, and you think about how a spreadsheet works, it's all just cell operations. And so when you think about MOLAP and OLAP in a traditional sense, it is like a big spreadsheet laid out on disk. And so you can do very powerful calculations spreadsheet style, versus when you think about SQL and the relational model, you're dealing with rows and columns, and you need to somehow group things together, and making relationships between one cell to another cell is very difficult. So MDX lets you do things, for example, like creating reusable time intelligence functions. For example, this year versus last year. That's very, very simple, but those are 2 points in time. Those are two different cells. Or doing what you would do in a spreadsheet, which is you do year to date. Okay, you're summing up a bunch of time, time elements to get to your current point in time. To do moving averages. These are all sorts of things that are pretty difficult to do in SQL, and you need to be a real pro and have lots and lots of temp tables to do. So what is XMLA? Well, XMLA is really, again, invented by Microsoft. It's just a protocol that allows you to essentially submit MDX queries, over an HTTP protocol. It's what Excel uses for their live pivot tables that talk to analysis services. That's an XMLA protocol. So you can think of MDX as the expression language. So SQL on steroids, SQL made for multidimensional. You can think of XMLA as a protocol like HTTP, but for XML. Now, when it comes to relational versus MOLAP, you want me to get into that, Andrew?
Yeah, just at a high level, because we'll cover it some more as we talk about data virtualization. But yeah, let's introduce it now.
So it's essentially the original OLAP or multidimensional OLAP meant that everything was materialized. So like I said before, it's like a big spreadsheet where you have cells, and that spreadsheet is actually written to disk. And then every single query will then do basically cell arithmetic to render a result. Relational OLAP, in contrast, doesn't pre-materialize the data. It's going to transform a multidimensional query into SQL and then execute that SQL against the relational database to get the answer. So two very different strategies. Obviously, pre-computed is going to be faster than it would be to calculate every single time. But we'll get into some more of that detail about just how AtScale in particular gives you the best of both worlds. But those are two big differences in the two different styles.
Yeah, and I think we can directly overlay that on newer terminology. Again, I'm going to do this for people who use Tableau because I know there's lots of them, and not everyone comes from let's say a Microsoft ecosystem. In Tableau, you have this import model, and you have this thing called Connect Live or Live Connection. So if we can connect live, that means we're not materializing anything. We're not extracting the data into a local model. And when we go ahead and do our analysis and we drill down and so forth, that generates queries that are sent out directly to the remote database. It's a little less immediate, but the data is more immediate. There's no latency. It updates automatically because there's nothing to update. We're going directly to the source. And so the Live Connect is basically what Molap was, and the extract is what Rolap was. So those acronyms may, sound old or unfamiliar, but the concepts, the exact same concepts are still here. If you're a Power BI person, then the comparable terms are import and direct query. Direct query would be the Rolap equivalent. So these are classic concepts that don't go away, and it's the same trade-offs too, by the way, right? If you materialize everything, then yeah, it's all local and you can query it super duper fast, but it also means you have a copy of the data. It also means that copy has to be updated every time the source is updated, and those are the different dials you need to kind of twist and turn and negotiate. The other thing I'll point out about MDX is that it has built-in constructs to understand the whole rigor of hierarchies. So if we want to drill sales down, let's say by country first, and then state or province within country, in SQL we can do that as long as we stack both of those things in a group by. But in MDX and in Olap, we can define those hierarchies from the beginning. We can very easily say, show me the sales for the United States and all of its children, or show me that for Canada and all of its children, and it just knows what to do. And also in terms of pre-aggregating, it knows already that if you've aggregated at the state level, then all you have to do is add up those state level aggregations to get the country aggregation. And that's an optimization, because that's a lot better than going all the way down to the detail level and aggregating again to get to the country level. If you understand hierarchy and you understand that some hierarchies are so-called natural hierarchies, you get a lot of optimization when you're doing analysis. And that is a very structured notion, but those exist, right? Those exist in the world of analysis all the time. We have hierarchies in business, and very often we want to aggregate in a way that's consistent with them. So that brings us to our first poll, and this particular poll, you get to select all that apply, not just one, but any. And we just want to kind of understand, since we've talked a little bit about different BI tools, what you guys tend to be using for your analysis. Again, not mutually exclusive. So maybe you're using a combination of BI tools and, let's say, working just writing straight SQL scripts, or maybe even writing Python scripts for Spark, or maybe working with notebooks. Check all that apply here. We're interested to understand where people are coming from, because some of these things are more or less oriented towards some of the concepts that we're talking about here. And so it helps us to understand contextually where you guys are from. Dave, what does AtScale kind of encounter with customers? Are lots and lots of people still working with the so-called most popular BI tool in the world, aka Excel? Are they working with more professional BI tools?
Andrew, we see sort of a combination of, it's always Excel plus a BI tool. So we see lots of Excel and Tableau. Also now lots of Excel and Power BI, but it's almost always both, and never one or the other. And then we also see, custom applications that are built on top of the AtScale virtual cubes. So a combination of really those three is what we see the most often.
Very good. All right. Well, let's see what the results are looking like. And I also just want to point out that you guys, as a public service, and I wrote about this for ZDNet, you put together a really nice high-level Olap model around a lot of the rather disaggregated tabular data around COVID-19. And you did that as a public service, and as I understand it, you're even working directly with a hospital network, a healthcare network in Boston with some of that work. But that directly, I think, demonstrates the value of this thing. Like if you want to go ahead and download the Johns Hopkins data yourself from a GitHub repo, you can. And if you want to bring in some demographic data from other sources and model all that yourself, you can. Or you can just connect directly to the model that you guys built from a BI tool, from Excel, etc. Okay, look at the the far and away winner here is BI tools, 85%, and then Excel a fairly close second at 65, and you see the rest here. We've got scripts at 50. Scripts will never go away. People with coding skills love to code because it's the most explicit way they can express what they want, and oftentimes, the most direct. The problem, I think, with user interfaces sometimes is that, because they're a metaphor, sometimes they create a kind of separation between, what you're thinking and what you want. Jupyter notebooks are not insignificant, not trivial, but they're in last place at 20%. So any surprises here, or is this pretty consistent? Sounds like it might be pretty consistent with what you've seen.
Yeah, that's like I said, it's always the BI tool and Excel, and then sometimes we see custom applications, which is that scripts kind of code and or SQL query tools that you see that's in third place. So it's right in line with what we've seen in the market.
All right. And again, I'll remind everyone, if you're using BI tools or even Excel, which is a BI tool, but it's a spreadsheet. If you're using pivot tables in Excel, if you're using a BI tool, then it's all about measures and dimensions. Even if the tool does a great job of making you not have to sweat that and deal with it, that is actually how it is organizing and structuring things. You don't have to do that explicitly. You can just give it a bunch of tables and it'll deal. But in effect, it's building an Olap model for you. And you were talking, Dave, a lot about analysis services. Anyone here using Power BI, in fact, you're using an updated version of the analysis services engine, whether you're doing it with Power BI Desktop or you're doing it in the cloud with the cloud service. And if you happen to be a Power BI Premium customer, and this, I think, it makes a point, support for XMLA on Power BI Premium was just added. And that shows how high the value is, right? You have to be a premium customer to get that XMLA support. That's how important it is, and that's a built-in thing for AtScale, if I understand it correctly, right? I mean, every AtScale virtual cube is I mean, you can take a straight JDBC, ODBC connection if needed, right? But XMLA is something you've supported natively, as I understand.
Yes, we support them both, right? And there's reasons why you want to support both, because the modern BI tools work best with SQL, especially tools like Tableau. But of course, that will Excel through a live pivot table is going to speak the XMLA protocol. So you need them both.
Excellent. All right, so now we move from talking about Olap, which is really about semantic models, measures, and dimensions, to data virtualization, which we don't necessarily think of in the same breath as Olap. Data virtualization is really about having kind of a broker, a query broker, a one-stop shop to get to all your data, but where that data is not actually all pulled in and ETL'd into a model like it would be in a warehouse, where essentially your virtualization platform takes your queries and understands where to go and get what data and what SQL queries to propagate and emit and push down. So we've listed a bunch of the benefits of doing data virtualization here, and I think a good portion of our audience will understand that, from the model of it, from just the logical side of it, virtualization makes a lot of sense. In practice, some data virtualization platforms, especially when you're issuing queries over multiple sources, a so-called federated query, most people understand that the performance on that is not always wonderful. But maybe you can explain, and that last rectangle all the way on the right gives some of this away, how Olap and virtualization can come together, and in doing that, how we can start to enjoy some of the benefits of the logical side and mitigate some of the performance issues that I mentioned some data virtualization platforms might suffer from.
Yeah, that's and this is really how AtScale works, really. So when we began to start to solve that problem of, okay, OLAP is great, except if you pre-materialize, not only do you create copies of data, which is bad, and you have to refresh it, but it also ultimately limits your scale. And so you just can't, you have to pick and choose what's worthy for analysis. And business users never want to do that because they never know what the next question is going to be. So what we did is we said, rather than pre-materialize, because we still need to deliver on that first sort of benefit of OLAP, which is queries that come back in a second or less, is that we will learn from the query patterns and from the model of the data. That tells us a lot, because the model tells us what the relationships are between the tables and the data itself. And then the users who are running queries are telling us what's important. So by putting those two together, we can create aggregations or aggregates automatically based on these heuristics as well as these patterns that we're learning from the user queries, and then we can store those back into the relational databases or data warehouses where the data is coming from. So what that gave us, Andrew, is it gave us the ability of delivering, having the best of both worlds, which is having a full OLAP model, having it be fast, but not having to pre-materialize and pick and choose what's worthy. And that architecture of having aggregations in those host data warehouses really then benefits when you run a federated query, because rather than having to take atomic data and move it over the wire to join table A, which is in platform A, to table B, which is in platform B, which may be in different data centers, we don't have to do that. So what we can do is that we can take the aggregations on both sides and just join the aggregated data versus trying to do a atomic join across the wire. And so the benefit of actually building that OLAP model and doing it in such a fashion where it's ROLAP, but ROLAP plus automated aggregations, then lends itself really well to doing a federated query at scale. Pun intended, I guess.
I think that pun was intended when you named the company, no? But yeah, and we know your history, right? You loved Olap. You were building these huge cubes, and I know this because I was on Microsoft's Partner Advisory Council for BI, reading the case studies of the stuff that it turned out had you behind it all. And so I think you loved the paradigm, but then you also told me some of the shark stories of, what it took to process those cubes overnight, and how that could get a little stressful. And meanwhile, then you were at Yahoo, or maybe I have that backwards, but at Yahoo, that's where Hadoop came from. We weren't even calling them data lakes then, at least I don't think we were, but you had one. And so I guess you must have seen the potential to put these two constructs together, and and therefore be able to do OLAP, but do it at scale, at big data scale.
Yeah, Andrew, you said building the cube. You said building the cube overnight, Andrew. No, at Yahoo, it took 7 days of 24/7 processing to build that cube. So it was if it was overnight, we'd be very, very happy, and maybe there would be no AtScale right now. Who knows? But no, we wasn't even close.
And I have to imagine that if that was truly a week-long process, that you must have been nervous if you hit a bump on the third day and had to set the clock back to 0 and start over. I don't envy you. That must have interrupted your sleep patterns pretty significantly.
Terrified for sure.
Yeah. So then it sounds like the compromise, and I don't mean compromise in a bad way, like we're giving stuff up, but the way we're reconciling all this, and I think this used to get called Olap, hybrid Olap, where your fact level data is stored in on the relational side, so it's rollup, but you're mitigating things by maybe not materializing a full cube, but by materializing some aggregations. Which is really no different from the same kind of strategy we utilize when we have a database and we cache some of the data, right? That's the point, is that stuff that gets frequently used, it makes sense to materialize that and then have some kind of smart algorithm for invalidating that once something underneath it gets updated. And then that way you don't have the latency in terms of updating, and you also don't have the latency in terms of, how long it might take your query to execute. So is that fair? Is that accurate, the way I just
that's very very much so. But another sort of thing to think about is that when people are trying to do this basically a DIY today without Olap and without that kind of engine, what they end up doing is they end up, Andrew, manually building these aggregates. And then the BI tool user and designer needs to understand what aggregate is appropriate for use in a dashboard or in an analytic, which is really hard, right? Because now you have users who have to be basically humans who have to be aggregate aware. And then understand the context of that aggregate, whether it's suitable for a certain analytic. So it really brings data engineering back into an IT specific, back into a critical path of the analytics chain, which is really a step backwards. And then the tools themselves are going to proliferate really these semantic discrepancies, discrepancies, because now you have a dashboard or an ad hoc user who are designing reports and dashboards that are maybe speaking a different language or be using different data altogether. So it's much worse, I think. I think we've taken a step back by sort of moving back to straight SQL, and we've taken a step back and created a lot more barriers for self-service, where now we're asking, Andrew, the business user to become a data prepper. We're asking them to be a data engineer. Right. We already did that with the data scientists, and now we're asking the business analyst to do the same. Not good.
Self-service is important because you don't want impediments for people, but if the self-service implementation involves multiple users, if not most users, sort of doing all that modeling work, the same modeling work themselves over and over at kind of the edges of the implementation, that's exactly the right candidate for saying, well, let's take this, let's make it common, and let's put it in the platform. That's what platforms are for, is to implement the stuff that otherwise everybody would have to do themselves over and over and over again. That's the value of a platform. And that allows users to say, okay, well, that rudimentary stuff is in the platform, and I can concentrate on the higher value stuff, which is all the insightful analysis and visualization that you might be doing. You shouldn't have to do all that plumbing.
I love that, Andrew. It's like you think about it, right? Like you said, it's what is programming? Programming is abstractions, and it's promoting reuse. And that's exactly what we should be doing with data is abstracting concepts from the physical and promoting reuse and consistency.
Yeah. Because otherwise, it's really an economic problem if we're making everybody kind of do that work, you know, on a bespoke basis, one by one, by themselves, over and over and over again. That just holds us back in terms of the progress we can make. I'll get down off my soapbox now, but so now let's try and understand. We kind of understand Olap on the one hand, we understand virtualization on the other, and we see where they have a common vertex between them. So we're starting to get this idea that they can work together really well. But on the other hand, you know, if we understand the history of Olap going all the way back to those early analysis services days, we do know that there were some downsides. We've listed some of those downsides at the bottom here. And we already talked about at least one of them, the cube processing time, in terms of your war story of, you know, having a cube that took a week to process. But you got a payoff after that week, right? You got a beautiful semantic model. In the cloud days, you were able to let people easily see what kind of social influence they were having. You know, for Yahoo, you tell me, but I guess a lot of it had to do with page views and advertising revenue, and lots of variations of different questions could be asked really easily. And I think the important the important thing about the right approach to analysis is if you can set it up so that somebody is not penalized for asking another question and another question and another question, if in fact they're encouraged to do analysis in an iterative fashion, that's the sweet spot. That's where you want it. You don't want to make people feel guilty or bad for investigating further. And so that's a sweet spot of Olap, is that there is no penalty. I mean, there is the penalty in terms of what you have to do to get ready for it, but once it's done, there's no penalty. So I don't know. I mean, you tell me, was this causing you, as the arrows on the slide might depict, was this causing you some schizophrenic dissonance where you're like, I love Olap, I hate Olap, I love Olap, I hate Olap. And then, you know, as you were starting to look at, you know, tens of terabytes, then going into hundreds of terabytes and even to petabyte scale, you know, how did that thinking progress?
Yeah. Look, this is definitely some PTSD here from my days at Yahoo and Clout, and you know, and it's worse than this, right? So back then, even, you know, for building that 7-day build cycle, you're right that I was terrified for 7 days, hoping that I didn't, you know, hit a blip and some one byte in the disk that caused it to fail and start over. But it also was only for 1 quarter's worth of data, so meaning 3 months worth of data. And of course, you know, my business users needed to do year-over-year analysis, which meant they really needed 5 quarters worth of data. So how did I do that? Well, I had to have 5 separate cubes to be able to be accessed, and then there's no way to combine those 5 cubes. So my poor users had to do that in Excel manually to do year-over-year analysis. So it's actually much worse than it sounds. And today, with the tabular model, so SSAS tabular, they've actually taken a step backwards in terms of scale, because now it has to be all in memory unless you go with a direct query approach, which is just not going to perform, and it's not going to give you the kind of sub-second query performance that you really want. So you know, I calculated, actually, given the biggest instance of SSAS in Azure is 400 gigabytes of RAM. That's the biggest instance. So if I were even able to do that with my Tau Cube, my Tau Cube at Yahoo, Andrew, it would have taken 6 instances and cost $1.7 million a year for that 1 cube. So we've taken sort of that Olap concept that was so powerful, and we kind of put it into a box that's made for only small data. And so, you know, with AtScale, you know, that bugged me to no end. right? Because again, I'm a big believer in this concept, but it has to work at today's data with today's data in terms of how it's stored, which is not necessarily a relational model or a star schema, and it needs to scale with the growth of the data, which means it's got to be able to, you have to have an architecture where pre-materialization is not a requirement. Or in contrast to what people are doing today, requiring that it fit in memory. That just does not work. You got to have an architecture that can support either. And so we think that we've really taken away the bitter with, and kept the sweet. And of course, there is no free lunch, Andrew, so if you're not pre-aggregating everything, it may mean that if our optimizer hasn't seen a pattern before, you may have to wait a little bit longer for that first query to render before it's optimal for subsequent queries. So there is no free lunch there. But we think that the trade-off is a reasonable one, and that you can have the best of both worlds with the right architecture.
All right, fair enough. That brings us to another poll. So here we're kind of focused on modeling, if you will, although, there's different levels of formality to modeling, and sometimes the modeling is a little bit more homemade, and that's okay. We understand that many of you may be using multiple of these approaches, but we're going to ask you here what your primary practice is. In terms of modeling your data, if you start at the bottom, we're talking about BI models and cubes on the back end. And then if you go all the way to the top, it's a much lower tech. We're talking about just writing ad hoc SQL queries on data that's in a warehouse. And, ostensibly the warehouse is, in fact, organized in a star schema with measures and dimensions set up that way. And then we've got some intermediate options. BI users might be modeling on the self-service basis, or maybe somebody is, let's say, building a Tableau workbook or a Power BI file that doesn't actually have any visualizations in it, but has all the data brought in and all the kind of pre-organization already set up. And maybe you're just writing SQL queries on your data lake straight up. That might be the most challenging of all, but it's still quite prevalent. So we'd be interested in understanding, which of these is your primary, and we'll let you kind of pound the buzzer and give us your verdict over there. Let's see. I wonder. I was just going to ask you maybe about you were talking about the tabular models and analysis services, which again is exactly what Power BI uses exclusively, in fact. They have created this option. If you're, subscribing to the service and paying for it, then you can actually mix and match where you have some things that are materialized locally and then other things that are accessed on a direct query, i.e. Olap basis. So you can have kind of hybrid models. But that sounds like it's a bit of an afterthought to deal with the drawbacks that you were talking about.
Yeah, well, look, you don't want to. You don't want to have to force the user, the customer, to be able to self-optimize, right? Because what that means is that they're going to have to basically architect it for performance, which is choosing what's pre-materialized versus what's not, and then build an ETL pipeline for the stuff that's not, so that the direct query is fast enough on its own when it's not pre-materialized. So it just adds a lot of complexity to the equation when you're trying to do that kind of architecture yourself. It's a DIY kind of a solution. So if you're good and you're really talented at it, have at it. But it's right. It's a tough thing to keep up and keep working right.
All right. Well, let's see those results. Here they are. Modeling done by users in BI tools on a self-service basis is our winner. And templates got 0%. Well, again, I ask this of everybody after our polls, but any surprises there? Dave?
Yeah, I'm not surprised at all. I think that most of, and at AtScale we actually built model importers from tools like Tableau, because what we found is that with that self-service revolution of using those tools, the modeling was actually being done inside the workbooks and inside the dashboards themselves. So that is the prevalent sort of model today.
That's the winner
it's
here.
one that,
yep.
and it's one that I think is problematic, right? Because that means that those models are all done on an individual workbook basis, and we have customers that have thousands of those.
Right. You're getting into the kind of spread mart, what we used to call the spread mart problem, where everybody kind of had different things on their own machines. We don't mean to disparage people that are doing this, because in fact we think in a lot of cases people don't have a choice, but there is a lot of inefficiency to it. And by the way, having a pre-built model that's consumable does not restrict or preempt you from doing your own modeling on top of that. But it at least in theory it should save you a lot of the groundwork. So hopefully this notion of semantic models and dimensional models, it goes, not just back to analysis services, but to things like why am I blanking on the name of the BI vendor that had universes as their semantic model?
Business objects.
Yeah, business objects, which has been part of SAP for quite a long time now, right? But those things still exist for SAP customers. I'm pretty sure, even with their newer cloud BI platforms, the universe is still a thing. So hopefully we can what's the word I'm looking for? We can catalyze a sort of renaissance and an appreciation of the value of semantic models in data and analysis. All right, now you kind of spoke to some of this already, but let's put the icing on the cake here and really draw it home. There's a fine point, a technology fine point that is alluded to here that I hope you can go into detail on. That's in the middle bullet. But all right, so you talked about, okay, let's keep the sweet, let's get rid of the bitter. In general, what we're talking about is modernizing these decades-old concepts and bringing them up to date for things like, the cloud and cloud data warehouses, which are clearly popular, right? I mean, Amazon tapped into something pretty resonant when Redshift was launched. For a long time, that was their fastest growing data service, was Redshift. And now we've got Snowflake, and on the Microsoft side, we have Synapse Analytics, and Teradata has a new life, or a new outlook on life. And data warehouses are, talk about sort of bringing back a classic concept for the modern era. It's been done. So then, in a corresponding way, how can that happen with Olap? And by the way, what is the problem with MPP, which stands for massively parallel processing? It's the technology that most data warehouses use, whether they're on premises or in the cloud. What is the problem with MPP and doing the kind of dimensional querying that happens in analytics?
So I discovered this in our early days when we were pioneering Hadoop at Yahoo. So and the way that tools or platforms like BigQuery and Snowflake work is very similar to that pattern. So how did Hadoop, or how does MPP deliver deliver speed that's linear in terms of in terms of if you have a 10 node cluster, that means you can distribute that data across all those 10 nodes, which means that now you're reading 1/10 of the data each for each query, which means it should go 10 times faster. And so the whole sort of premise behind MPP is to distribute the data evenly, so that when you read it, it can be n times faster. Well, what happens when you want to join two tables together? So now what happens is that if you have different segments of each table on different nodes, now you can't simply just scan the data in parallel. Now you have to shift data across that network, which may be a slow network, to be able to get your result and join those two tables together. So as a result, these MPP architectures are pretty horrible at joins. And then what is, the star schema? Well, the star schema is very, very join centric. It is facts and dimensions joined every which way. So normalization in a modern cloud data warehouse is a dirty word. And if you do a search, you just go do a search on Google BigQuery data warehouse best practices, and they'll tell you that joins are bad. So that what they want you to do instead is to denormalize your data, so that rather than joining two tables together, those two tables will be folded amongst themselves in a single row, which is a fine way of modeling, especially with nested data types. But a lot of our customers, when they move to the cloud, they bring their star schemas with them, and by doing so are very disappointed at the results. So one of the things, Andrew, that we do, that AtScale does to mitigate that, is that we can handle the star schema in a cloud data warehouse environment because we create those aggregates, and basically we denormalize the data automatically, which is really what works best for these modern cloud architectures. And that's really the key. So otherwise, what you need to do when you move to the cloud is to remodel your physical data out and away from a star schema into a more nested and denormalized schema if you ever want to get any kind of performance in these cloud data warehouses.
Yeah, I think one of the nice things about, if you understand the way that the data warehouse works, you have your measures in a fact table, you have your dimensions in dimension tables, and then when you go to do a dimensional query, it has to join the fact table with any relevant dimension tables. The nice thing about the cube is that actually happens when the cube is built, right? You don't get rid of that star join, but with the cube, you get it over with, really. And then your model makes it a more natural thing where you don't have to jam everything together on the fly. So it sounds like you've found a way to capture some of that upside. We have just a couple minutes left here. Just wanted to see. Okay, great. So we've been talking about the value of building this kind of a model over a warehouse, but how and I'm not giving you much time to respond, but how feasible is that really over a lake, where a lake is really a bunch of disparate data sets, often in CSV format. Maybe if we're lucky, they're in Parquet files, which are columnar, on the same order that a warehouse might be. How does that work? In practice, how have you mentored customers to set up a semantic model over something as, what's the word I'm looking for? Fragmented, really, as a data lake?
That's a great question.
Frag the lake.
So the way we do it is, like, there's a lot of, almost every cloud vendor has a way of putting a table structure on top of a file in the lake. Amazon has Athena, they have Spectrum. So you have Databricks on Azure. Through Spark, you're able to put a table on a raw file. So that means, Andrew, you can then model that data as a table. So now
Okay.
these data lakes are slow though. So what we do is we allow you to model on the raw data, but when we create those aggregates, we'll place them into a high performance data warehouse like a Google BigQuery or a Snowflake or a Redshift, which gives you the best of both worlds. So the atomic data stays on the cheap storage, and you get fast performance and only data that's required on your high performance data warehouse.
And I don't have to do that modeling in the warehouse and then go to you. You're saying you'll connect those dots for me.
Exactly.
Sounds like.
Yep.
Okay. All right. Well, that's a relief. Basically, I mean, this is the problem I find with pretty much all the major cloud providers. You know, despite my experience with lots of Microsoft stuff, I don't think they're any better on this than Amazon or Google. Is that the cloud providers are great at giving us all these different, you know, services as building blocks. They're not so great at integrating them and putting them together. That leaves a lot of work for me. That's a lot of assembly required. What you're saying is with AtScale, you'll take maybe what I did in S3 and the semantic modeling I can do with you, and the fact that I might need a Redshift or a Snowflake as an intermediate execution layer, like you'll deal with that for me. I may need to procure it, but you'll engineer that as an artifact of what you guys do. Sounds like
We'll make it all work together. Yep, we'll make it all work together.
Yeah, which is not something you're going to get from AWS directly, even if you are using Athena. So awesome. We're at the top of the hour. That was fun going down, no pun intended, memory lane. And I think we brought it all the way up to date at the very end, talking about things like Redshift and Athena and S3 and so forth. So thanks everyone for tuning in and going through all the rigors of all of this. At times it's, you know, it's detailed, but it's really, really important stuff. And I note that almost everyone who started with us is here at the very bitter end, Dave. So I thank you for that. I will credit you for that. And I'm sorry our hour's up because we have to say goodbye. But thank you very much for being our guest and our sponsor. And I'll wish everyone in the audience a good rest of their day or evening. For GigaOm, this is Andrew Bruss signing off.